Okay, let's look at the homework 7, problem number 28. Right. So we want to summarize the pertinent information obtained by applying the graphing strategy and sketch the graph of this function f of x equals 2x times quantity x minus 2 cubed. Right. So let's do that. Alright, so first thing that we need to find is a domain, right? So domain. Alright, since this function is polynomial function, so domain is all real numbers, so you can basically plug in any real number you want. So domain is from negative infinity to positive infinity, right? So that will be the domain. So let's type it in. All right, so we can just say parentheses negative infinity to positive infinity. Right. All right, let's check the answer. All right, we got that. All right, so next question, what is the y-intercept? All right, so we want to find the y-intercept. All right, so let's do that. All right, so we want to find the y-intercept. All right, if you want to find the y-intercept, what we do is we're gonna have to set x equal to 0, right? So which means that let's see, so y equals, right, basically just evaluate the f of 0, which is going to be, plug in 0, it's going to be 0, right? So y-intercept is 0, right? So that was the domain. Alright, so let's type it in. Alright, so y-intercept is 0. Alright, let's check the answer. Alright, got that. Alright, next one is x-intercept. Let's find that. Alright, so x-intercept, x-intercept. In order to find the x-intercept, we set y equal to 0, right? So that's going to be, right, so we have to set the whole function equal to 0. So we're going to have 2x times quantity x minus 2 to the third power. We set that equal to 0, right? So this way, we have a couple x values, right? We can set this guy equal to 0, right? So there we can get the x equals 0, right? And we can set the other factor x minus 2 equal to 0. So if x minus 2 equal to 0, x is going to be 2, right? So x-intercepts are 0 and 2. Alright, so let's type it in. Alright, x-intercepts are 0, comma, it's not typed in. Alright, hold on a sec. Alright, it is 0 and comma. Alright, so 0, 2. So let's check that. Alright, we got that. Alright, so what are the local maximum? So we're looking for the local maximum, right? So let's do that. Alright, so in order to find the local maximum, we need to take the derivative. So let's take the derivative. So f prime of x is equal to, right? So 2 is just a constant multiple, so I put it outside. Right, then I'm going to take the derivative of x times, so we have two things multiplied together. So here is our first guy, and here's our second guy. So let's take the derivative using the product rule. Right, derivative of the first guy is 1 times the second, which is quantity x minus 2 cubed, right, plus, right, first guy is x times derivative of x minus 2 cubed would be, put 3 in front, and the same quantity x minus 2, raise it to the, subtract 1 from the power, so it's 2, and then multiply by derivative inside, which is just 1. Right, so we have that. All right, so let's try to clean up a little bit. So let's factor, take the common factor. So you see that there's x minus 2 squared here, x minus 2 cubed. So we can factor it out. Right, 2 is already there. So x minus 2 squared. Right, so what's left is, okay, so 2 is already taken care of. Right, then x minus 2 squared is always already taken care of. All right, so what's left is, all right, so you have another x minus 2 from the first term, so x minus 2, right, that will take care of this guy, and also 1 is already taken care of. Right, then you have 3x. All right, so you have plus 3x. Right, so that would take care of the rest of it. So 3x. Right, one doesn't really do much. All right, so we just need to clean up here. So this is going to be equal to, right, so this is right here is actually 4x combining x and 3x and minus 2. So you have another 2 here, so I'm gonna pull that out. So 2 is already here, 2 from here makes that 4. Alright, then you have a quantity x minus 2 squared. Alright, then 2 is factored out, so you have a 2x minus 1. Right, then we're going to set that equal to 0 to find the critical value. So this is going to be, right, x equals 2. By setting this guy equal to 0, we get x equals 2. Right, and we set this guy equal to 0, so that's going to be 1/2. So 1/2. Right, so those are the critical values. All right, so we found the critical value. So we want to find the local maximum. So we're going to do a number line here. All right, so put 1/2 here and 2 here. All right, then separate these. All right, so we know that the first derivative f prime, right, f prime is going to be 0 at the net 1/2 and 0 at the x equals 2. Alright, so let's determine, let's see, on this interval, so any number less than 1/2. So let's try 0. So f prime of 0. Alright, so if you plug in 0 here, right, so if you plug in 0 here, actually there's a square here, this guy is always positive, right, so 4 is always positive, right, only difference is this guy. If x equals 0, it's -1, so it's negative. So positive times negative would be negative, so it's going to be negative here. Right, and we can try for this one, you can try x equal 1, so f prime of 1. Right, if you plug in 1 here, right, Only difference is 1 here. 2 times 1 minus 1, so it's positive 1. So it's gotta be positive here, which means that on this interval it's always positive, right? After 2, we can try f prime of 3, right? So if you plug in 3 here, 2 times 3 minus 1 is positive, so it's all positive, so it's going to be positive there. All right, so we have that. I can erase this. All right, so let's see, we want to see if there's a local maximum. You can see that it's a decreasing to increasing, so this is going to be a local minimum. So right here, you're gonna have a local minimum, right? Here, sign doesn't change, positive to positive, so this guy is neither here, right? So it looks like there's no local maximum, right? So let's type that in. All right, so there's no local maximum, so click on that, so check the answer. All right, we got that. All right, so next one, local minimum. So we know that the local minimum occurs at x equals. All right, so we did that, so go back there. All right, looks like local minimum occurs at the x equals 1/2. So let's type that in. All right, so x equals 1/2. All right, so let's check the answer. All right, got that. All right, so what are the inflection points? All right, so we are looking for inflection points, so we have to take another derivative, so let's do that. All right, so in order to find inflection points, we need a second derivative, so we're going to take another derivative. So f prime, double prime of x is equal to, all right, so 4 is a constant, so put it outside. All right, then you have two things multiplied together. So here's the first guy, here's our second guy. All right, so let's take the derivative using the product rule. All right, derivative of the first is going to be 2 times quantity x minus 2, right, raise it to the first power, times derivative inside is going to be 1, so I'm not going to write that. Right, multiply by the second, which is 2x minus 1. All right, plus, right, first guy is a quantity x minus 2 squared times derivative of the second guy is 2. Right, so let's clean that up. All right, so you have let's say you have 4 here, and also 2 is in common, so 2 is here and 2 is here, so pull out 2, combine with 4, so 4 times 2 is 8, so 8 is out here. All right, then also we have x minus 2 here. You have x minus 2 squared, so I circle that, so I know that there's another x minus 2. So factor out the quantity x minus 2. All right, then you have leftover stuff. So we have 2x minus 1, so 2x minus 1, and you have x minus 1 minus 2, so x minus 2. All right, that will take care of 2x minus 1 and x minus 2. That's left over, so that's everyone. All right, so let's do a little bit of cleanup. You can see that here, if you combine that, you have a 3x minus 3, right? So it means that you can pull out 3 from there. So 3 and 8 combined, 24. Then you have a quantity x minus 2. Right here, if you pull out the 3, so you have x minus 1, so x minus 1, right, and set that equal to 0 to find x coordinates of possible inflection points. So it's going to be x equals, right? We can set this guy equal to 0. We get positive 2. We set this guy equal to 0. We get positive 1. Alright, then we'll do another number line. So I'm gonna do it up here. So you have a number line here. This time we are looking at the sign of the second derivative, so f double prime. Right, so put the tick marks so for 1 and put tick marks for 2. Right, so here we know that the derivative, I should say second derivative, is 0. So you have 0 here, you have a 0 there. Right, so we just need to look at the sign. So any number less than 1, so I'll try 0, f double prime of 0. Right, so plug in 0 here. Right, so that's going to be negative 2, so that's negative. 24 is positive. Right, 0 minus 1 is negative. Right, positive times negative is positive. So we know that the positive here and the positive there. Right, so if you try anything between 1 and 2, so we have to try double prime of 1.5. Right, so if you do 1.5 minus 2 is going to be still negative, but 1.5 minus 1 is actually positive here. So it's positive times positive is negative. Right, so there's a concavity change at 1. Right, and after that, let's see, we can try f double prime of let's say 3. Alright, then you have 3 minus 2 is actually positive, 3 minus 1 is positive, all positive, which means that there's positive here. So you have a concave up here, so there's concavity change. So we know that there's going to be an inflection point at x equals 1, because concavity change, so you have an inflection point there. Right, and there's a concavity change here, so it's an inflection point at x equals 2 as well. Alright, so let's type it in. Alright, so inflection points are at x equals 1 and also at 2 as well. So let's check the answer. Alright, we got that. Alright, on what interval f is increasing or decreasing? So let's look at the number line for first derivative. Right. Alright, so looking at the number line here for the first derivative, so on this interval, since derivative is negative, it's decreasing. So we know that f is decreasing on, right, from negative infinity to positive 1/2. Right, and after that seems like it's always increasing, so it's increasing on, right, from 1/2 to positive infinity. Right, so let's type it in. Alright, so it's increasing on, let's see, 1/2 to positive infinity. Alright, and decreasing on from negative, oh, I didn't put the parenthesis, oh, sorry. Put the parenthesis, right, negative infinity to 1/2. Alright, so let's check that. Alright, got it. Alright, what interval f is concave upward and downward? So let's look at that. Alright, so looking at this number line, we can determine, so f is concave upward on Alright, so it's positive here and a positive there, so it's going to be from negative infinity to 1, and also 2 to positive infinity, and a concave down on between 1 and 2. Right, so let's type that in. Alright, so concave upward on interval from negative infinity to 1, and also 2 to positive infinity, right? And concave downward on interval from 1 to 2, right? So let's check the answer. Alright, so we got that. Alright, then we need to pick the correct picture. Alright, so let's go back to the answer, previous answer here. Alright, so we know that, let's see, increasing on the interval from 1/2 to infinity, and decreasing on from negative infinity to 1/2. So it's decreasing, after that it's increasing. Right, let's see if we have that. Right, decreasing, after that increasing, decreasing, after that decreasing here, so B shouldn't be it. It's not even decreasing here, it's not even decreasing. So A is actually the only answer that that's reasonable. So let's check the answer. Alright, so that's that. Alright, that's it. I hope that this was clear.